In this presentation, we will understand shallow copy in details. So without any further delay, let's get started with this lecture and let's see what are the topics. There is only one topic and the name of the topic is shallow copy. Before understanding shallow copy in details, first we need to recall the concept of copy constructor because we will use copy constructor to properly understand shallow copy. So now let's recall copy constructor. Here is the quick recap of copy constructor. Copy constructor is used to create a new object as the copy of an existing object. With the help of copy constructor, we can define a new object as the copy of the existing object. That is why it is called copy constructor. Here is the example program we took in order to understand the copy constructor. This is the copy constructor, and this copy constructor is invoked because of this line. Here we have student S2 equals S1. Here we are trying to create the new object S2 based on the existing object S1. Here we have the reference S to some object. This reference is the reference to S1 object. So here, in place of s.roll number, we have s1.roll number, and here we have s1.name. Because s2 has invoked this constructor, so here we have s2.roll number and s2.name. So this line is same as s2.roll number equals s1.roll number. Therefore, s2.roll number will hold 112 because s1.roll number is 112. In the same way, s2.name will hold John because s1.name is John. Now, we know when we execute this program, we will get this output because of display function called on s1 and s2. We are getting the same roll number and same name for both these objects. So we have successfully created the new object as the copy of the existing object. This is how the copy constructor works. Here we are creating the copy of the existing object and we are passing it to the new object. This in reality means that we are copying the member values of one object and we are passing those member values to the members of some other object. In this case, we are creating the copies of the member values of S1 and we are passing the copies to the members of S2. In this way, we are creating the copy of the existing object and passing it to the new object. This is the concept of shallow copy. Shallow copy means copying only the member values. We only copy the member values. That is what we call shallow copy. This means actual content is passed for simple data members like int, float, char, etc. We took the example of simple data members only. Roll number and name are simple data members. For those data members, actual content is passed. This is what we saw. But in case of pointers, addresses are passed. Now, in case of pointers, we know addresses are passed when we are talking about shallow copy. Because addresses are passed, shallow copy has some limitations. Now we will address those limitations one by one with the help of a C++ program, and we will also understand the meaning of shallow copy. We will get to know why shallow copy is called shallow copy. Now let's write a simple C++ program to understand the limitations of shallow copy. Here is the example program. Here I have defined the class student and this is the definition of the main function. Currently the class is empty and this function only has just one statement, return 0. Now let's define a private data member name. This is the character pointer. This means this is the pointer to a character. Now here I have defined the pointer to a character to point to a specific string. You might be thinking that this is the pointer to a character. So how it can point to an entire string that can have multiple characters? This is what we will learn now. For now, just understand that with the help of a pointer to a character, we can point to a specific string. This means we can access all the characters of the string. Now here, inside the main function, let's define the object of this class and let's name this object S1. Here I've defined the object S1 of class student and I am trying to initialize this object with the string John. I eventually want that this pointer should point to this string. For this purpose, we will define a constructor. In order to initialize the object, we need to define the constructor. This is what we learned. But before defining the constructor, I want to tell you something about this string literal. We know this already, this is the string literal, and therefore we cannot modify this. But do you know how this string literal is stored in memory? This string literal is stored as an array of characters, and that array is non-modifiable because that array is stored in a read-only section of the memory. This is how the array looks like. Here in this array, we have all the characters of this string literal. Each block of this array has some address because each block is representing a memory location. The address of the first block is 100. This is just my assumption. The remaining addresses are always in increments of 1. This is because these memory blocks are consecutive. They are one after the other. That is why these addresses are in increments of 1. If we somehow know the address of the first block, then calculating the remaining addresses is not at all difficult. This means if we know the first character, then we can access the remaining characters as well. This is the essence that a character pointer can point to an entire string. Now let's understand how. First, let's define the constructor of this specific class. This is how the constructor looks like. This is the constructor student with the parameter n. This is the pointer to a constant character. Now you might be thinking why I have defined a pointer to a constant character. Here I want to initialize this object S1 with the string John. This means the constructor will receive the string and we want to receive it somewhere. That is why I have defined this pointer. This pointer will hold the address of the first character of this string literal. Because passing the string to a function is same as passing the address of the first block of that string. The address of the first block is 100. We are passing the address 100 and that is why we need pointer here. I hope this is clear to you. And this pointer must be a pointer to a constant character because this is the constant character. This character is constant because we cannot modify this character. I hope this is completely clear to you. So, one thing is clear that n is pointing to this specific character. Now, as I have mentioned this already, n is holding the address 100. We know the remaining addresses are in increments of 1. This means from this address, we can access the remaining addresses as well. And this also means if we know the first character of the string literal, then we also know the remaining characters. That is why I was saying that a character pointer can also point to a string, not only just character. So we can say that this pointer is pointing to this entire string. So in this function, we can access this string literal without any problem. I hope this is clear to you. Now, we want that name should also point to the string literal. For this purpose, we can easily pass n to name by writing name equals n. In this way, the name pointer will hold the address of the first character of the string literal. But that is what I don't want to do. Now, there is one reason why I don't want to do this. Later in this program, we may want to modify this string. But because this is the string literal, we cannot directly modify it. For this purpose, I want to create a new array and copy this entire string to that new array. The new array must be modifiable. This is what I want to do. So inside this constructor, I will create a new array and I will create the copy of this string and pass it to the new array. Now I do not want to create a normal array because it is possible that later we decide to change this string to some other string of different length. That is why I want to create a dynamic array. And we know how to create a dynamic array. We can do this with the help of the new operator we learned in the last lecture. This is how we can create our dynamic array. I'm using the new operator to create a dynamic array in the heap memory. Here I'm creating a character array of a specific size. Size is specified within brackets. Here I have provided this function strlen. This is short for string length. As the name suggests, with the help of this function, we can find the length of the string. We need to pass the string to the function. Here I have passed the string with the help of the pointer n. And I want to mention this, that this strlen function is declared in C string header file. So we need to include this header file. Now we can use this function here. With the help of this function, we will get the length of the string, which is 4. So we will get 4 here. Now here I have added 1 to it. This is because I want one more memory block in the array to store a special character called the null character, which is represented by \0, and it represents the end of the string. It is needed and we do not have to add it on our own. It will be added automatically. But at least we should have memory for that character. For this purpose, I have added 1 here in this size. So we know we will get 5 here. This means we will get a total of 5 blocks to store characters in the heap. We also know with the help of new operator, we will get the address of the first block that we can store inside a character pointer. Here we have this pointer name, which is a character pointer. Therefore, it can hold that address. I hope this is clear to you. Also, you can observe that S1 is the object which is invoking this function or this constructor. Therefore, here we have S1.name. So we can say the new array is S1.name with 5 blocks where each block can hold a character. Here we have these indices from 0 to 4. This is how the array looks like. The last block is reserved for the null character. S1.name is holding the address of the first block. This means through this specific pointer, we can access the remaining blocks as well. Therefore, we can say S1.name can access the entire array. And that's why the name of this array itself is S1.name. This is how we can imagine it. So now we know this is how S1.name looks like. Now after this, we want to copy this entire string to this new array. For this purpose, we can use this function strcpy, which is short for string copy. This function is also available in this header file. Now we can use this function. We need to pass the destination and the source to it. Destination is s1.name. Here we want to store the string. The string that we want to store should be passed as the second argument. We have passed this as the second argument via the n pointer. Now we know after execution of this code, we will get this string over here in this array along with \0, which is automatically added at the end. We do not have to add this \0. This represents the null character. So this is how our array looks like. This array is situated in the heap memory. So this is the dynamic array. So this is how we can define the object of this class S1 and initialize it with the string John. We can initialize it with any string. Array will adapt according to the string. Now what's next? First, let's remove this array because we do not need it. We need to focus on this array only after this point. Now let's create a new object S2 and let's initialize it with S1. This means now we will create a new object as the copy of the existing object S1. This is how the new object S2 looks like. Student S2 equals S1. Here I'm trying to copy the S1 to S2. So we know that the copy constructor needs to be called, but the copy constructor is not defined yet. Let's define the copy constructor like this. This is the copy constructor, which has the reference to some object of this class. Here I have specified constant because the reference will not change. This is the reference to S1. So we can say here we have S1.name. And because this constructor is called by S2, here we will have S2.name. So S2.name will hold the address stored in S1.name. The address stored in S1.name is the address of the first block of this array. Now S2.name is also holding the same address. Therefore, we can say S2.name is just another name of the same array that is situated in heap. I hope this is clear to you. Now these two pointers are pointing to the same memory location, the same array. Now let's define the display function to display name on the screen. Let's call the display function via S1 and S2. We know we will get the output, name John twice. And this is because of these two objects, S1 and S2. It seems like we have successfully created the copy of S1 as S2. But it is not true. We have not created the true copy of S1. You will get to know about this in a moment. You can understand this by seeing this code and by seeing this array. Here we can observe that S1.name and S2.name are pointing to the same array. Therefore, if we make any change to this array via one object, then it will be reflected in the other object as well. This is not the true copy. The copies must be independent of each other. S2 must be independent from S1. Therefore, if we make any change to this array via S2, it should not be reflected in S1. But that is not the case right now. And I can demonstrate this at the moment. For this purpose, let's define a new function setName. Let's replace this constructor by the function setName. I have removed the copy constructor because copy constructor will be provided by the compiler. We do not have to worry about this. Here I have defined this function setName that can accept a specific string, and it can provide the string to this array. Here I am calling the setName function via the S2 object, and I am passing the string Mike to it. This string will be passed to this pointer. Eventually, with the help of strcpy, we will copy the string Mike in this array. Here we have name as the destination. We know this is same as S2.name because setName function is called from S2. So through S2.name, we are making this change. Here we will get the string Mike. I hope this is clear to you. This array is modifiable. That is why we can see this new string in this array. Now we can also observe that the change made by S2 in this array is reflected in S1 as well. S1 can see this change, and therefore when we execute this program, we will get this output. S1.display will give us this output, name as Mike, and S2.display is also giving us this same output. So, it is clear that changes in one object will affect the other too. This is the first limitation of shallow copy. We got this limitation because of passing the addresses in case of pointers. We have passed the address stored in s1.name to s2.name. That is why both these pointers are pointing to the same array. Making changes via one object is reflected in the other object as well. And this is the limitation of shallow copy. This is what shallow copy is. Shallow copy means surface level copy. We are passing only the member values. The member values are copied. In case of simple data members, actual content is passed. That is not at all a problem. But in case of pointers, addresses are passed. This is the root cause of the problem. Here we can observe the problem. Now here is one more limitation of shallow copy. That is what we need to address now. We know that we have defined this array in heap, that too with the help of the new operator. Now, after doing all the work, we need to deallocate this memory as well. And we can do this with the help of delete operator. Delete operator can be passed to this destructor that is called student. This is the destructor student and it always starts with tilde. We will learn about destructors later in detail. For now, understand that this destructor will be called via both the objects S1 and S2. When the program completes its execution, then the destructor will be called on both the objects S1 and S2. When the destructor is called on S2, here we will get S2.name. Delete operator will deallocate this array because S2.name is representing this array. Now what happens when the destructor is called on S1? Here we will have S1.name and the delete operator will work for S1.name. But S1.name is representing the same array which is already deleted via the destructor of S2. So here we have the double deletion and this is called the double deletion problem. I hope this is clear to you. Destructor is already called on S2. Memory is deallocated for the array. Now the destructor is called again on S1 and the memory is already deallocated. Here we are double deleting the same memory and this is problem in C++. Here I have written the summary. Destructor of S1 and S2 is trying to delete the same memory, causing double deletion problem. We must avoid this problem at all costs. This problem is caused by passing the addresses in case of pointers. That is, this is the problem that has arisen because of shallow copy. I hope this is clear to you. So we have two limitations in case of shallow copy. The first limitation is, if we make any change via one object, then those changes will be reflected in other objects of the same class. This is because of the shallow copy. And the second limitation is the double deletion problem. Destructor is called twice to delete the same memory location. So, now we want to address these limitations. We want to remove them somehow. In order to remove and resolve these issues, we have something called deep copy. Deep copy is the concept which we will understand in the next lecture. For now, we are done with the shallow copy concept. This means we are done with this topic and we are done with this lecture. Okay friends, this is it for now. Thank you for watching this lecture. I will see you in the next one.